Hello everyone, welcome to Mr. AP. Today we will be going over all of the AP Computer Science A 2024 FRQs. I'm just going to be going over the solutions, kind of how I thought about the solutions, and yeah, so let's just get started. All right, so the first FRQ, question simulates birds or possibly a bear, blah blah blah. Personally, I don't really care about this information here. The only thing I want to look out for are these variables that are already initialized for me because I'm probably going to have to use them. But these descriptions are just going to be down below even better. So I can kind of just skip all this and just go straight to part A. All right. Write the simulate 1 day method, which simulates birds or possibly a bear at the feeder for 1 day. The method determines the amount of food taken from the feeder on this day and updates the current food instance variable, which was defined above. And the simulation accounts for normal conditions, which occur 95% of the time, and abnormal conditions, which occur 5% of the time. Under normal conditions, the simulation assumes that on any given day, only birds visit the feeder, and that each bird at the feeder consumes the same amount of food. The standard amount consumed is between 10 and 50 grams of food inclusive in 1 gram increments, so the bird can eat 10 to 50 grams of food. The amount of food eaten by each bird on a given day is randomly generated, and it can be an integer from 10 to 50 inclusive. All right. This is some good information here. For example, a run of the simulation might predict that for a certain day, each bird coming to the feeder will eat 11 grams of food, and if there's 10 birds on the feeder to that day, there will be 110 grams of food consumed. Okay. There's no table for this one down below, so we can't see specific numbers, but this is a good enough example. And we have 3 more examples down here. So if the feeder initially contains 500 grams, the call simulate 12 will result in 12 birds eating 20 grams, leaving 260 grams. Here, the feeder initially contains 1,000 grams of food, but the call simulate 22 resulted in a bear eating all the food, leaving 0 grams. So this was the abnormal 5% condition. And then here, the feeder initially contains 100 grams of food. The call simulate 5 results in 5 birds attempting to eat 30 grams of food. And since the feeder initially contained less than 150 grams, the feeder will now contain 0. So even though the birds ate more than there is, we're just going to put 0 for the food count. All right, so let's get started with part A, public void simulate 1 day. So it's important to notice this void here. This means you're not going to be returning any values in this method. Okay, so let's go ahead and let's start by creating the normal and abnormal conditions. So immediately when I think of a percentage chance from 1 to 100, I use math.random. So here, I'm going to account for the abnormal chance, the 5% chance. So we're just going to do math.random less than 0.05. And for those of you that don't know what math.random is, it will give you a number from 0 to 0.99. So we're doing less than and not less than equal to because we're counting 0. So here we'll have 0, 0.01, 0.02, 0.03, 0.04. So that's 5% chance. And when the abnormal condition happens, the bear eats all the food. So we're just going to set current food equal to 0. Again, because of this void here, we're not returning current food. We're just setting current food as a value. And this will make sense more in part B. Okay, so now we're going to account for the normal condition, which we can just use an else to go to. Now I'm going to create a variable that stores how much food each bird is eating. So now you'll notice I'm actually using the int here, and let me just write this out and then I'll explain why. Okay, so the birds can eat anywhere from 10 to 50 grams. So here, I'm going to multiply by 41, and I'm going to add 10 here. So let me just explain what's happening here. This is going to calculate a number from 0 to 40.99. But I'm turning this into an integer. So that means we're going to get a number from 0 to 40 because 40.99 when it's an integer or whatever, like 40.5 or something, that you're going to get 40 point something, and that's going to round down to 40. So this will give us a number from 0 to 40. But the food is supposed to be from 10 to 50. So we just add 10. And that's that part. Okay. Now I'm just going to store this. And I don't think you need to store these parts in variables. If you just wrote them out, that's fine. I just want to do it this way for clarity. So now I'm calculating how much of the total food was eaten by multiplying how many birds was put in the parameter by the number that we just calculated. All right. Now for the next part, I'm just going to check when I subtract current food minus this, if it becomes negative, because if it becomes negative, we don't want to store a negative number for current food, right? We want to store 0 because that's what it told us to do. So here I'm just comparing if this is a negative number, and if this is a negative number, current food just becomes 0. All right. And now I think we just do an else statement here to close this out, and current food will now be will now equal current food minus the total food that we calculated from numbers. All right, that is all of part A. So yeah, not too bad. If you're not really comfortable with math.random, this could be a tricky one because you do have to do some specific stuff with math.random. But other than that, it's not too bad. The key thing is just remember you're not returning a value because of the void. You are just setting current food equal to 0. So let's move on to part B for FRQ number 1. All right, we're going to write the simulate many days method, and this method uses the method that we just created to simulate num birds or a bear coming to the feeder on at most num days consecutive days. The simulation returns the number of days that birds or a bear found food at the feeder. Okay, so let's just look at this example to get some clarity on what's happening here. So if the current food starts with 2,400, and we call simulate many days 10,4, so 10 is the number of birds, and then 4 is the number of days. We're going to see that we run simulate one day 4 times, and we're subtracting from the current food every time we call that, and we leave with this with 1,260, and our method is going to return 4 because on all 4 days of the simulation, birds or a bear found food at the feeder. Okay, now let's see what's happening here. We have 10 birds and 5 days. After day 1, there's 150 grams left, but after day 2, we drop to 0 grams. So because in 2 days we got down to 0, the simulation will return 2. Now here, if we start with current food at 0, the simulation is returning 0 because there was no food to be found on any day. So we're returning 0 days. All right, so doesn't seem too bad. I feel like this one might be easier than part A, which is kind of surprising. But let's just write method. So make sure to include the 2 parameters, but I don't think you need to write this method because College Board already wrote it out for you, so that's fine. And the way I did it is I have 2 counters. So obviously I'm going to have the counter for the number that I need to return, right? How many days actually were successful. And then I'm going to have a counter for a loop because I'm going to use a while loop. Now, I'm pretty sure you could use a for loop, but the way I did it was using a while loop, and let me just show you how I did this. So 2 conditions I want to check for is if current food is greater than 0, because if current food is at 0, then we're going to return 0, right? So we don't need to run this while loop. The second condition is if my loop counter is less than the num days. And this is because we only want to run the loop how many days we were given, right? So the next 3 things I'm doing don't really matter the order that you do them because nothing in this loop really affects each other. So let me just write this out and then I'll explain what's happening. Okay, so so if current food is greater than 0, that means that we're having at least 1 successful day, right? So we need to add to the counter that we're going to return, and then we're adding to the loop because 1 day has passed for this part. And then the whole thing is that we need to run the method we just created, simulate 1 day, so that current food can actually get updated. We don't need to update current food in this while loop. We're just using the method we just created to do that. The reason why the order doesn't matter is because, like, as we saw in the example, let me just bring it back up. Even though after the 2nd day there's 0 grams left, we're still counting that day as successful. So we're still updating the counter that we're going to return, right? And then the last thing that we need to do is just return the counter. And there we go. So the reason why we're returning is because of this in here. It's not a void. I'm pretty sure it also specified in the prompt to return. But yeah, part B was not too bad. Not sure how the point distribution is going to work. You probably need to use a loop somehow. You're probably going to have to need a counter. You're going to need to call simulate one day and then return the count. That's how I'm assuming the points will be distributed. But yeah, FRQ 1 was not too tough. And now we're going to be moving on to FRQ 2, which also is pretty easy in my opinion. All right, moving on to FRQ number 2 for CSA. This is probably going to be the easiest FRQ, at least in my opinion, and from what a lot of people who have taken this test say. Because on this FRQ, you are making a whole class and a bunch of methods in the class. But College Board actually gives you like everything. If you scroll down, there's a table down here and it tells you like everything that you need to do. Basically, it tells you the return types and stuff I'll explain on the way while we're coding this. So I guess we can just start off by reading the question. So this question involves a scoreboard for a game. The game is played between two teams who alternate turns so that at any given time one team is active and the other team is inactive. During a turn, a team makes one or more plays, and each play can score one or more points and the team's turn continues, or the play can fail, in which case no points are scored and the team's turn ends. The scoreboard class, which you will write, is used to keep track of the score in a game. So the scoreboard class contains a constructor and two methods. All right, so let's just start off with the easiest part. This should be like a free 1 to 3 points, making the constructor. So the constructor has two parameters. The first parameter is a string containing the name of team 1, and the second parameter is a string containing the name of team 2. And the game will always begin with team 1 as the active team. So this part leads me to believe there's going to be at least a third variable that we're going to have to make in this class. So to start here, we just have to create our class. We just do public class scoreboard, and then the fancy bracket. And then let's start initializing some variables that will be that our constructor will create. So we're gonna have the two team names, and then we're gonna need something to something that will keep track of which team is active. Now there are many ways you can do this. The way that I did this was using an integer, and I'll explain how this works later. Now, I'm going to leave some room in case we need to create more variables, because sometimes, like as you go on with the FRQ, you realize you need more variables. And you can either leave space for yourself to do that, or you can just create all the variables on one line, which is actually what I did on my CSA FRQ. All right, now we're going to make the constructor, and there's going to be two parameters, which were the two team names. And what I do to make it easy is I just label these parameters as A and B, because it just makes it easy, because you're only going to use these like here, and then you're going to use them again when you're actually initializing the variables. So we're going to go ahead and team 1 is going to equal the first name, and then team 2 is going to equal the second name. And then here I'm going to set active equal to 2, and I'll explain this in 1 second. So it says that team 1 is going to be active, and the way I'm going to keep track of which team is active is by using modulus division and checking if the number is even or odd. And since team 1 starts as active, I'm going to start with an even number, and then if we switch to the other team, I'm going to add 1 to that counter, which will create that number odd, and then it'll keep going back and forth like that. Another way you can do this is by creating a Boolean flag and just doing if statements to change the Boolean to true or false. Okay, so now we need to start looking at the other methods. So here, if we read record play, method has a single non-negative integer parameter that is equal to, actually, let's start with the get score method, because this one I feel like is easier, and I just want to get all the easy stuff done out of the way. I actually started with FRQ number 2 on my exam because of how easy it is, and I just always want to get the easy stuff out of the way to get those free points. So this method has no parameters, and the method returns a string containing information about the current state of the game. The return string begins with the score of team 1, followed by a hyphen, followed by the score of team 2, followed by a hyphen, followed by the name of the team that is currently active. Okay, so here, it shows that we're going to need to keep track of the scores of the two teams. That means that we need to go and create two variables for the two teams' scores. So we can just make score 1, and then we can make score 2. All right, now we need to initialize these variables, and both teams just start at score 0. So because we didn't put the scores in the parameters, we're just going to initialize them to 0. And that's going to be our whole constructor. Spoiler alert, there's no more variables that we'll need to make. And now we can make our getter method. So it said it returns a string, and then I believe getScore was the method. Okay. So we just make our getter here, and there was no parameters. So we're done with that part. And now here's how we're gonna check what message to return. So it said you return the team 1 score followed by a hyphen, followed by team 2 score, followed by a hyphen, followed by the active team. So that means we're gonna have to have 2 different return methods, messages. At least that's how I did it. If you guys have faster or easier ways to do this, please let me know in the comments. I'm always happy to learn about new solutions. But here, I'm just checking which team is actually active, because then depending on which team is active, that changes the score. So now I'm just writing the return method message. So score 1 followed by score 2 followed by the active team, and since team 1 is always active first, we just have team 1 here at the end. And now I can just make an else statement for the other return statement, and we don't actually change the scoring. You just keep the same score 1 plus score 2. Same hyphens and everything. The only part that's going to change here is actually team 2. We're going to return the name of team 2. Okay, so that's actually our whole getter method. So we've already finished like most FRQ. I believe if you have this down, you get like 6 or 7 points as long as you've done everything correct here. So now we're going to make our last method, which is record play. And this method has a single non-negative integer parameter. So that means we're going to put something in the parentheses. And it's equal to the number of points scored on a play, or 0 if the play failed. If the play results in 1 or more points scored, the active team score is updated and that team remains active. If the value of the parameter is 0, the active team returns end, and the inactive team becomes the active team. This does not return a value. That's key. So if it doesn't return a value, that means we're going to have to make a public void method. And then it was called record play. Cannot spell. All right. And I'm just going to put, it said it had 1 integer in the parameter, so I'm just going to label it point. We can make this points because you could get more than 1 point. All right, so first I'm going to check if the points is equal to 0, because if it's equal to 0, we're not updating any scores, we're updating which team is active. And here, I'm just going to add 1 to the active counter. So first we start with 2. 2 is the active team. If 2 mod 2 does equal 0, so this returns the active team. Now when we add 1, we're going to get 3 for active. 3 mod 2 does not equal 0, so we're going here and we're returning the team 2 statement. And we're going to do the same thing here. So now we're just going to make an else, and I'm going to make an if statement in the else statement. And I'm going to do the same thing I did up here. If active mod 2 equals 0, then we're going to update score 1 because team 1 is the active team in that scenario with the points that was put in the parameter in the method. All right, and then just going to finish this off, and then we can just do another else. No need to write the whole active mod 2 thing again. Score 2 plus or equals points. And that's your whole FRQ number 2. It may look like a lot, but I mean, you really just have to make sure you initialize your variables correctly. By the way, it's very important that you put private here, because I'm pretty sure if you don't put private here, you do not get the points for actually making these variables. So this part's very important. And then if you did all this correctly, making sure that you set these to, make sure you don't declare values up here, you're declaring all the values in the constructor. And then your get score, you're just going to return statements depending on which team is active. And then here, depending on how many points there are, you're just going to add those points to the active team. So yeah, let me know if you guys had an easier solution or how you would like my solution, and let's go on to the next FRQ, FRQ number 3. All right, now we are on FRQ type 3. This is going to deal with an array or an array list. So let's see. This question involves the manipulation and analysis of a list of words. So an array list, which is stated right here, array list of strings. All right, cool. So again, I don't really care about this stuff. I just see that we're going to use an array list here, and it's already declared for us. So we're probably just going to have to like modify it or something like that. But let's see when we go down. You can read this, but I think it's more detailed if you just go down. So that's what I'm going to do. Oh, see, not that much stuff, and this should have everything we need. So write the is word chain method, which determines whether each element of word list, except the first one, contains the previous element as a substring. The following table shows 2 samples of is word chain method calls. So if we have word list filled with an, band, abandoned, it's going to return true because an is in band is in band, and band is in abandoned. Now if we have the list of two, stool, tools, 2 is in 2 is in stool, but stool is not in tools, so we're returning false. All right, this doesn't seem too bad. The key things here is that we are dealing with an array list, and I'll explain why this is very important. All right, so public boolean is word chain. So here we can see the boolean, so we need to make sure that we're returning something because it's not a void. So right off the bat, I don't think there's any variables we need to declare, and I'm going to explain why. So one of the most important things is when you're starting this loop, you're starting at 1. The reason for this is because of this here, except the first word. And I'm going to show you how this loop works. So we're going to start the counter at 1, and we're going to go until the length of the array list. But since it's an array list, we need to use .size and not .length. If you use .length, unfortunately, I'm pretty sure College Board is going to be taking away a point here because .length does not work on an array list. You need to use .size. So now I'm just going to check if the first word works with the second, is in the second word. So what I'm going to do is, again, this is the special thing about array lists. You need to use .getI. You can't just do word list brackets I. You need to use .getI. So I'm getting the word at I, which is at the index 1, and I'm checking if there's an occurrence of the word before this one in that one, in that word. So how I'm going to do this is I'm going to do word list.get I minus 1, right? The value before the one we're checking. And I'm just checking if this is equals to -1. The reason why I'm checking if it's equals to -1, if you don't know how index of works, the great thing about this exam is that there is a reference sheet and you can go and look at it, and it'll tell you that index 1 returns a value if this is found in this. In this case, this is the first word and this is the second word in the array list. Now, if this word is not found in this word, then it's going to return -1. And the great thing about returning -1 is we only need to check if if one of the words is not found in the array list, right? And immediately, if we know that one of them is not found, we can just return false. And returning false here is going to automatically end the loop. And then we can just return true, because if we've gone through the whole loop and we've never returned false, that means that this word, the preceding word, was in the next word every single time through the array list. And that's it. That's all of part 1 for FRQ number 3. So let's move on to part B now. All right. Write the create list method, which creates and returns an array list string. The method identifies strings in word list that start with target and returns a new array list containing each identified string without the starting occurrence of target. Elements must appear in the return list in the same order as they appear in word list. Consider an example where word list contains the following strings: catch, bobcat, catch a cat, cat, and at. The following table shows array lists returned by some calls to create list. In all cases, word list is unchanged. Okay, so we're going to make sure we don't modify word list. We're going to be making a new array list in this method. So if we called with the parameter cat, we're going to get an array list that's returned with ch, cat, and then nothing here. So the reason for that is because only these words start with the word cat. And what we're doing is we're removing the word cat from these words. So if you remove cat from this, you get ch. If you remove cat from this, you get ch, a cat. And if you remove cat from cat, well, you have nothing left. So you just get an empty string. Same here, we can see if we are looking for the word catch, we just remove catch from catch, we remove catch from catch a cat, and that's what we're returning. If we have dog, we're getting an array with nothing because none of these words have dog in them. Okay, so let's start to make this. All right, so the first thing we're going to do is I like to declare the methods, even though you don't need to. But let me just quickly type this out. Okay. So the first thing it told us to do was to make a new array list. So how to do this? You just do array list string. And then you can name it whatever you want. I just like to name, whenever I do a new array list, I just like to name it resized, but you can name it anything. And then we're just going to do new array list string, and then make sure to include those parentheses. There you go. We have now created a new array list. All right, so now let's do what the prompt is asking us to. We're going to do a for loop. This time we're starting at 0 because we're checking every single word, and we don't need to like do -1 or anything like that. Although maybe you could, but you're just making it too complicated if you do that. And we're going to go through the whole list. So again, we need to make sure we do .size because we're dealing with an array list. And then we're just going to add the loop. All right. So here we're just going to, this is going to be a pretty big if statement, but this is going to check if the word here is in the word list. All right. So how I do this is word list.getI. Remember, you have to use .getI for array list to get the word at the index, and we're going to use substring, which again is on your reference sheet. So if you don't know how substring works, you can go look at the reference sheet, which is very nice, very generous from College Word. And what we're going to do is we're going to get the substring of only the beginning of that word so we can compare it easily to target. And how we do that is we just go from the start of the word to the length of target. Now here we're using length because we're looking at the length of a string. So in case you don't know how substring works, let's say our word was catch and our target word is cat. This is going to start from the index of 0, so C, and go until the target length, which is 3, because cat is 3 letters. And this part's inclusive, this part's exclusive, so we're going to take the index of 0, index of 1, index of 2, so CAT. And we're going to check if that substring equals our target word. And now, hold up, okay. If the beginning of that word equals the target, then that means we're going to have to add that word to our new array. But we're going to need to remove the beginning. So how we do this is we use resize.add because it's an array list, so you're adding to the array list. And now I'm going to add only the part that I need, which is everything after the beginning of the word that matches target. So I'm going to do this. I'm going to use .getI again, and I'm going to do the substring starting from the target's length. Now, the reason why I don't need two things in the substring here is because if you just put one variable in here, it's going to go from this variable until the end of the word. So again, if our word is catch and our target was cat, we are effectively starting from the end of the word cat, so index 3. So that means we don't include index 0, 1, 2, which is cat, CAT, and we're just including the CH because we're starting from index 3 and going until the end. So from 3 to 4, 3 and 4, CH. And we're adding that to the array list. And there we go. We have created our new array list. The last thing that we need to do is just return the array list. Again, this is not a void method, so we need to make sure we return an array list string. There you go. That is all of FRQ part B. If you guys have any easier solutions or you need me to clarify on something, please let me know. And let's move on to the last FRQ, which was definitely the most trickiest FRQ. FRQ type 4. This is arguably the hardest one on the exam. At least for me, it was pretty hard. I actually didn't know what to do for part B at all, so I don't think I'm getting the points for that one. But anyways, let's just start with 4A. So type 4, you're going to have to deal with the 2D array, which is right here. And this is a 2D array of integers. So here they're showing us a whole class. So this is like what we made in the type 2 FRQ. So we got our public class location. We have initialized the row and the column. And then we have a constructor that gives the row and column values for the location object. And then we can get the row and we can get the column. All right. And now this is what we're gonna have to make. So again, this is like probably the most important part. They're giving us a 2D array of integers, and we're gonna have to make sure we use this on both parts. This stuff is all down below, so let's just go down. All right, 4A. Write the getNextLock method, which returns a location object that represents the smaller of the two neighbors of the grid element at row and column, according to the following rules. So the rules are that the two neighbors that are considered are the element below the given element and the element to the right. So if this is our element, then we're looking at 11 and 3 because it's below and to the right. If both of the neighbors do exist, then the location of the neighbor with the smaller value is returned. Two neighbors will always have two different values. If only one neighbor exists, the location of the existing neighbor is returned. So this is our grid, and these are a bunch of method calls we can test. So if we test 0, 0, again, this is 0, 0, one below is 11, one to the right is 3. Both of these exist, so we're looking for which one's smaller, which is 3. Here, though, we're looking at 4, 3, which is 25. Nothing exists below it, so we're just returning 6. And that works same for 2, 4. There is only something below it, nothing to the right, so we're returning the 1. All right. So let's write the getNextLock method. So this one kind of spooked me a little bit because I usually feel like you have to use loops, right, when dealing with 2D arrays. So for this one, actually, there's a solution where you can just use a bunch of if statements, which I guess is kind of shown here because of the if and the if, right? This is what we're going to do. First, I'm going to initialize 2 variables. These are not needed, but this is just going to make it much easier for me to code the next stuff. So I'm going to initialize the row below the one we're given, and then I'm going to initialize the column to the right of the one we're given, right? Because those are the two values we're going to be checking throughout this method. So now let's start with the first if statement. This is going to check if there actually is a value below and a value to the right. So to do this, we need to take the 2D array and we need to check if there is a value below. And okay, that's a value below. And the way I'm checking if these values exist is I'm comparing them. I'm sorry. I skipped too far ahead. Okay. For the first if statement, the way I'm checking if these values exist is if the row is less than the row, like how many rows there are. So for example, this one has 5 rows, right? 0, 1, 2, 3, 4. So if our given row was 3, for example, I'm checking if the one below it at row 4 exists by comparing this to how many rows there are on the grid. So there's 5 rows, and our value under this one is 4. 4 is less than 5, so it doesn't truly exist. And I also need to check if the column exists. So to do that, I check if the column is less than how many columns there are in the 2D array. So if you didn't know, you can do grid and then bracket 0, and this will give you how many columns there are. So in this case, there are 5 columns, 0, 1, 2, 3, 4. So again, if we're checking this value, which is column 3, we add 1 to it, we get 4. 4 is less than 5, and it's good to go. All right, so let's write out what happens if these values do exist. So now we need to check which value is smaller, right? Because we're going to be returning the smaller value. So to do this, we just check the two values, compare them to each other, and see which one's smaller. So what I'm doing is I'm checking if the one below is smaller than the one to the right. Nope. And then column right. And then if this is correct, then we can simply just return the object at those locations. So here we see that we need to return an object, and I'm going to put new object. I'm not actually sure if this new part is required here. I think it's just like a good measure to put. And then since we just checked if the one below is smaller than the one to the right. If the one below is not smaller than the one to the right, then that means we need to return the one to the right. Cool. Okay. Now we need to check the other statements. So if only one neighbor exists, the location of the existing neighbor is returned. So how I like to do this is by using else if statements. And I'm basically just doing what I put here, but I'm separating them. So I'm checking if the row below exists. And if it does exist, because we already checked if both of them exist, right? So if this failed, that means that one of these don't exist. So now I need to check if they individually exist. And this, if this is less than grid length, this means that the one below does exist. So we need to return the one below, because then that means the other one does not exist. Okay, and then I can just use an else statement to finish this off. And then row, column. And there we go. We have returned every single scenario. So yeah, this one was just, there's probably a way to do this like a shorter solution, but this is just the way that I like to do it because it's pretty clear to me. So again, we're checking, let's say we have this value. So we're checking this. This part is true, this part's not true, so we're not going to run this if statement. We're going to run to the else if. This part is true because this row is less than the grid length, so we're going to return this location. All right, let's move on to part 4E. Okay, this one is what really messed me up. But when I actually looked at it now, it's really not like that long of a method. It's pretty short. So, all right. Write the sum path method, which returns the sum of all the values on a path in grid. The path begins with the element at row, column, and is determined by successive calls to get next lock. So the method we just used. So that means we're going to have to use that method that we just made in this method. The path ends when the element in the last row and the last column of grid is reached. For example, consider the following contents of grid. The shaded elements of grid represent the values on the path that results from the method called SumPath11. So it returns 19 because it adds all of the numbers on its path. So we start here and we need to end here. Right. And that's all the info we're given. Okay, so public int SumPath. So we're going to be returning an integer. Public int SumPath. And then we are given a row and column to start with. Okay. Now, you don't need to... Oh, actually, I do think this variable will give you a point if you declare it. And this is simply the first value that we start at. So there are two ways I believe to do this. One way is to use a while loop, which I'm going to show. Another way is to use recursion. I'm not too good with recursion, so I don't really know how to deal with that, but I'm just going to use a while loop. And what we're going to check in the while loop is we're going to run the loop until we are at this last value. Because we need to basically keep calling the method we just made, which was get lock, I believe. Yes, get next lock. We need to keep calling that until we hit the end of the 2D array. So what I'm going to do is I'm just going to check while the row is not equal to the last value, which is just grid length -1, and while the column is not equal to the grid, the length of like how many columns there are. Again, we can just do this. We're going to keep running this loop. And what's going to be happening in this loop? We're going to be finding the next location that we need to go to, the next grid. And by doing this, we're going to call the next lock method with the row and the column. And then what we need to do after that is establish a new row and column for the next time we call this. So to do that, we're going to get the row of the next spot by using get row. And then we're also going to get the next column. Okay, and now what we need to do is we need to keep adding all of the spots we're going over, right? So how we do that is by adding to the sum that we initially initialized. Very important you have that like counter or sum. And that's going to be our whole while loop. And this is going to keep running again until we hit that last value. And when we hit that last value, we're done. We just return sum. And that is all of FRQ4 Part B. During the exam, it looked much tougher than this, but it's actually just as simple as that. So again, let's just quickly run through this. So we start at 1, 1. This is our first value, 3. And then we're running this loop. This is not equal to the last value. So we're doing get next lock, which gives us this. And we need to take the row and the column of this so that we can get the sum, right? By calling the grid, because the grid holds the actual value. So we need to call a grid with the row and column that was found by get next lock. And we're just going to keep running that until we keep get next lock is going to keep calling. We're going to keep going. And then we go to the last one. And here, row is equal to grid length -1 and column is equal to grid length -1. Grid bracket 0 -1. So that means we stop, and we're just going to return the sum because we have been keeping track of all these numbers. And that's it. Let me know how you guys did this solution. There might be more ways than while loops and recursion. I would love to hear in the comments. But overall, what did you guys think about these FRQs? I thought that they were not that tough, other than FRQ4 was really tough for me on the exam. But yeah, I hope everyone did good on their CSA exam. I'm hoping to hear back with a lot of 5s. And yeah, if you haven't already, make sure to like and subscribe. We're going to be posting more FRQ walkthroughs for Calculus BC, Physics 1, maybe Physics 2, and maybe other APs. Depends how many people we can get to cover them. But anyways, hope you guys enjoyed the video. Hope you guys learned a lot. And if you guys are if you guys are taking CSA in the future and you're looking to review FRQs, I hope this helped you. And you can also join our Discord server if you want to ask us more questions, CSA related questions. I'm always happy to answer what I can. All right, guys. Thanks for watching. Bye.